question that brought us together was to better understand the habitability of planet Venus. While other planets have been the subject of these kind of questions for a very long time, like Mars, for example, Venus has been largely overlooked because of very hard conditions to observe the surface and different missions that we had compared to other planets. So we felt that now was the moment to try to address this question, as we do have a fleet of new missions that will be addressing Venus exploration in the forthcoming years.
Hello everybody, and a very nice morning here in Leiden in the Netherlands. I would just say a couple of words because we are one of the co-organizers, the European Astrobiology Institute. My name is Wolf Geppert, I'm the chair of the European Astrobiology Institute, and wish you a very pleasant and very fruitful meeting here.
The final goal from this week, from this workshop, is to really identify where the knowledge gaps are. Next steps are built on have a sort of clarity in where we are going, what we want to do, what are the questions we want to answer, and boil it down to the main ones, the one that the community is feeling more urgent or more important to be addressed, even though it's in the far future. We are around 50 people, and the idea is to have a discussion center kind of event. So really having people to sit at the same table and have a melting pot of ideas. And then mixing those groups up and having those groups talk together and confront from very different disciplines, very different point of view, very different backgrounds.
Usually you would think habitability is more related to what happens at the surface and from the atmosphere, but the point is actually that the interior is strongly coupled with the atmosphere. So you have, consider Earth, well, that's the best example, where we have plate tectonics, and plate tectonics transports material into the interior, where first you had kind of reaction at the surface. You store carbonates, you store water at the surface and bring it down. And this is kind of a circulation, which is obviously required for Earth to have a sustainable condition at the having constant temperature at the surface, yeah, for a long time. That is basically the idea.
Geology is very important because in the geological records, when we have the registry of the past of the planet, the processes, the materials, if there was even life on Venus and was and had some kind of legacy, it would be in the rocks, in the atmosphere, it would be in the past evidence of what happened before, and rocks are like books. So if we want to learn about past history, we go to the books. With regard to planetary evolution, the rocks are the books where the history is written.
My angle is radar science, right? So I work a lot with Magellan imagery and all the radar products, and basically I'm trying to help the surface people sort of understand all the information we have currently from the data point of view, and especially how the new radars that will come can help constrain some of new aspects of the surface that we haven't been able to constrain yet. And of course, then we enter in the whole discussion of how that, links with signs of habitability in the past, and that's, it's a very layered kind of like long road ahead.
Most of my research is involved in looking at hypothetical climate histories for Venus. The idea being that if Venus had an early habitable phase, so a phase when it had temperatures and conditions similar to what we see for Earth through time, then maybe life began living in those times and eventually evolved similar to as it has on Earth. And then as the planet transitioned from being a very temperate world to the hothouse world we see today, that perhaps the life was able to evolve into new ecological niches where it could survive to the present day. So we believe that in the present day, the really most viable ecological niche on Venus is really the cloud layers, where we have temperatures similar to present-day Earth surface temperatures. We have pressures similar to present-day Earth temperatures. And what we've discovered from reanalyzing previous data from Venus, that we have pHs, so acidities, maybe not as strong as we once thought, and also importantly, UV fluxes that are not so high, because we're a bit closer to the sun, of course, with Venus. UV fluxes and in general photon fluxes will be higher than they are at Earth. But we see in the cloud deck that there's enough shielding from the clouds above the lower cloud deck that the UV fluxes are not so bad. So what we see is that life on Earth, if it was living in the clouds of Venus, some of it could actually be able to do photosynthesis, as we understand on Earth, both directly from the sun through the clouds, and it turns out also from the surface, because the surface is also radiating radiation in the infrared, and you can do photosynthesis with those photons as well.
The presence of an atmosphere is almost a requirement for habitability, because for habitable conditions to arise, you need to be able to perform complex chemistry either on the surface or, let's say, in the vicinity of a planet. And in order to do so, you need stable physical and chemical conditions. And as far as we know, only an atmosphere can provide such a stability. On airless bodies, the variations are just way too large, and the availability of material is also scarce if you don't have an atmosphere to keep both the conditions in terms of pressure, temperature, and also the availability of the required molecules in order to have chemistry, then biochemistry, and then life arising.
I have been reanalyzing old data collected in 1978 by the Pioneer Venus Large Probe. This is data that was analyzed way back then, but then the data was put away in a closet and stored on microfiche. And then we realized, this team that I work with, we realized that perhaps this data set had other pieces of information that were left unanalyzed. So I got the data set and I spent the last 4 or 5 years analyzing it, and we've uncovered new information about the atmospheric composition and the composition of the aerosols. And I believe it's going to open some doors for the potential for the clouds, Venus's clouds, to be a habitable environment, or something that's close to being habitable. A phrase I'd borrow from what's called the Decadal Survey refers to Venus's clouds as being on the edge of habitability.
This workshop is focusing on Venus habitability in particular. So the Envision mission has many topics that it's covering. We want to understand the evolution of Venus, of the planet through history, its present state, if it's active today, but also its climate and how the climate is linked to the surface, and how it's been shaped through history. So we try and understand the evolution of the planet, but part of what we want to look is also traces of whether Venus could have been habitable in the past, and today to at least characterize the environment so that there is more information to understand whether there could be habitability today. Some of the future missions also will do some sampling through the atmosphere, but we agreed that more sampling is needed, and in the future, for example, balloon missions where you can have instruments on board that can measure the droplets, their compositions, their size, and in order to home into whether microbes or life could be in the clouds, you would need to have something there to do more accurate measurements, and also to measure more inside of the cloud to understand if the conditions there are suitable for life.
When you go to a conference, you have to present something, you have one Venus session, it's very intense. While here, suddenly someone told us, oh, you have 5 days to talk about Venus, go play, have fun. And this is amazing, I'm super grateful for the organizers and everybody who made it happen, because this kind of relaxed environment where you can talk about all the problems of Venus really fosters ideas. Like I've been seeing it all these days, the chats we had, and when you get to know someone and suddenly they tell you something that they were thinking about, and you click immediately, oh my god, this is a great idea. I think this is the place where these things happen, this kind of workshop. So I mean, I'm very happy.
Funny thing for me is that there's a real large interest in the habitability of Venus. This workshop has really opened my eyes to say that people across these sciences, from geology, physics, atmospheric sciences, chemistry, they're all interested in the potential for habitability, and that there's less skepticism and there's more positivity that maybe there is something here, and that it's worth working towards to really see if there was a potential for habitability in the past, and then right now, what's happening in the clouds right now. And there is this general interest towards that, which that's the major takeaway I'm getting.
We didn't know when we brought all these people together how the dynamics and discussions would go, but from the first day, people were just very thrilled to be here, to meet up with the people and to learn from each other. And I think the discussions have been very good together. We have already very good ideas, and I'm excited what we will see tomorrow when we wrap up, what the final recommendations will be. But we were pleased with the people who came here and the dynamics that came out of it and the discussions we managed to have together. So, at least from my point of view, I'm very happy so far.
The idea is to really bring everything together into a commentary paper that can be published in as open access as possible to the entire community, so that everyone can have the idea of what the community is looking for and also contribute to that, because in this workshop we do not have any technology kind of aspect, but they also might have something to say for the forthcoming mission, also even future mission of future generations of missions. And that would be very interesting to have also bring these ideas outside the strict science-related community and have it spread out. This is the objective, the main objective that we want to come out. So bring it back to the entire community. I think it went very well. There were a lot of brainstorming, a lot of ideas came up, and I think also a lot of collaborations are happening. So I think that the workshop overall was very successful. We are already thinking about more than the next one, what this the idea can lead to. So other different kind of cooperation, different groups that can tackle specific ideas that came up, or possibly mission proposals for the forthcoming years. So this is what we're already thinking about for the forthcoming years.